So in section 9.5, we're going to start with radical equations. Of course, I don't have anything with radicals here at all, but the point I want to try and make with some of these simple equations is what you do to solve equations. Of course, you're looking for a number that you can put in here that'll solve this, but how would you solve, what would your steps be to solve something like x minus 8 equals 11? What are you going to do to both sides? Yeah, you're going to add 8. And here you're going to subtract 7. What are you going to do over here?
Multiply by 6.
Yeah, multiply by 6. So instead of dividing, you're going to multiply. Instead of adding, you're going to subtract. Instead of subtracting, you're going to add. Instead of multiplying, you're going to divide. All these things kind of fall under one general heading. You're doing the opposite operation. So when it comes to solving equations like this, which is our first example here in section 9.5, what's the opposite of a square root? What's the opposite operation? I mean, I need to get my hands on what's inside here, but what's the opposite of a square root?
Square.
Squaring it. Excellent. Now, to make that a little bit more clear, let me remind you of stuff that we just finished up on, and that is something to the square root. I can write that as a power. So I can write this as 1/4 x minus 6 raised to a specific power. Does anyone remember what power that would be?
1/2.
To the 1/2 power. Yeah. So these two things are interchangeable, but let me make clear what Austin said just a minute ago, that squaring this is going to undo the square root. I'm going to do it right over here. So it's 1/4 x minus 6 to the 1/2 power, and I'm going to square both sides of this. So let me put parentheses around my parentheses. In this case, I'm just going to use brackets so that visually it's a little bit easier to see. And maybe I'll do the same thing over here. But we're going to square both sides. Now, on the right-hand side, that's just 7 squared. 7 squared is 49. But how about on the left-hand side? What do these two exponents do when I remove this bracket? Liam?
They cancel out.
Yeah, they cancel out because they multiply. 1/2 of 2 is 1. So this really gives me 1/4 x minus 6 to the first power, or better yet, just 1/4 x minus 6. Nice. Now, there's a few ways you can solve this. One of them would be to add 6 to both sides and then multiply by 4. Another one is to multiply by 4 right away, and then take care of whatever constant is left over. Personally, I think I'm going to get rid of the 6 first. So that's 1/4 x equals 55. And then again, the opposite operation. Instead of multiplying by 1/4 or dividing by 4, I'm going to multiply by the reciprocal. So what's the reciprocal of 1/4? 4. So basically I'm going to multiply both sides by 4. So multiply by 4 here and 4 here. 4 times 1/4 is going to cancel. That's fine. That gives me x. X equals 220. Yay. Now you don't have to write it as something with exponents. I think for the most part we're just going to solve things with the radicals right here, just understanding that if it's a square root, we're going to square both sides to simplify. And that's fine. So you can do the square of the square root, square that and square that, and get 1/4 x minus 6 equals 49, and blah, 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 we ended up with x is 220. Now, just like everything else, you can check your answers on these problems. How would we check our answer in something like this? Yeah, plug it in. 1/4 of 220, well, it's 55. 55 minus 6 is 49. Square root of 49 is 7. So it checks. Now in this section in particular, checking your answer is gonna be a little bit more than just a good idea. It's actually gonna be something that's part of your problem. But let's work a few problems and get going on that first before we start worrying about something called extraneous solutions. Bless you. We're good on example A? All right. Let's see. Oh, it's the wrong section. Here we go. Let's try another one. Square root of 5x minus 11 equals 2. So example B. Square root of 5x minus 11 equals 2. Now what you're going to want to do is the opposite operation. We need to get our hands on that x. And the only way we're going to get our hands on the x is we got to get rid of the radical. So I'm going to square both sides. What equation is going to pop out? Ryan? What equation is going to pop out of this?
5x minus 11 equals 4.
Perfect. 5x minus 11 equals 4. And then just add 11 to both sides. X equals 3. Okay. But let's get in the habit of checking our answers. So if I plug that back in, so we'll do a check. 5 minus 11, does that equal 2? If I plug in that 3 here, I end up with 15 minus 11, or 4, square root of 4 does equal 2. So it does check. Like I said, there are good reasons for having to check that a little bit more carefully in this situation as opposed to some of the other stuff we've done in this course. But hopefully, you know, at least some of these are going to be pretty straightforward in terms of the problems for you. Let's try example C. No, there's another part to example B, so let's do that one. And this one's going to start changing things up for you a little bit, making it more interesting. Square root of 6 minus 2x equals square root of 7, or excuse me, 7 times the square root of x minus 3. So again, we want, you know, to square both sides to get rid of the square roots, but we got to be a little bit more careful in squaring both sides because I've got radicals on both sides, and in particular here I've also got a 7 times this radical. So what I'm going to carefully do is put parentheses around both sides. So this one and this one, and then square it. Now on the left-hand side, you know, that one should be pretty straightforward. Naja, what do I get on the left-hand side, please?
6 2x
Mm-hmm. You want to keep going?
plus
Equals,
or equals
yeah.
7 square root of x minus
It's,
or 49.
excellent. So the 7's not under the square root, but it still gets squared. So 7 squared, and I think you said that was 49, that's perfect. So it's going to be 7, and then when I square this, I just get x minus 3. So x minus 3. So 6 minus 2x equals 49 times x minus 3. So 6 minus 2x equals 49x minus, I think that's 157, no, 147. So, okay. Now of these two sides, the left-hand side or the right-hand side, since they both have the variable, I'd probably put the variable on the right-hand side because 49 is bigger than negative 2. So I'll add 2x to both sides and get 6 equals 51x minus 147. Now that you got the variable on one side, you put the constant on the other side. So I'll add 147 to both sides. You get 153 equals 51x. So 153 equals 51x. Divide both sides by 51. And at this point, you feel at least a little bit better because you got a nice even number. Not always guaranteed about that, but looks good here. But how can we be a little bit more confident in our answer? Okay?
Check it.
Yeah, check it. And if I put in a 3 here, well, let's see what happens. Square root of 6 minus 2 times 3, does that equal 7 times the square root of x minus 3. So let's squeeze that 3 in there. 3 here, and 3 here. So let's see, I end up with the square root of 0 equals 7 times the square root of 0. Or 0 equals 0. Is that true? Yeah. Feels kind of basic or something. Maybe a little unsatisfying, but it's true. It does work, so x equals 3 is our solution. No problem there. But let me stop for a second and show you why we actually have to check our solutions. It's not just kind of a good idea anymore. You actually have to check your solutions. So you don't have to copy this down. Let's start out with a very simple equation like, say, x equals 4. And hey, that's it. We're done, right? I mean, you've got your answer right there, x equals 4. But keep in mind what we've been doing to both sides of our equation. We've been squaring both sides of our equation. Okay, so that would give me x squared equals 16. That's fine. I'll move the 16 to the other side and get x squared minus 16 equals 0. Having just finished a test on this stuff, I hope that you can factor x squared minus 16. Prove me right. X and x.
+4 minus 4.
Awesome, +4 and -4. Austin's piling up the extra credit here today. Good job. All right. But if you look at this, I've got something times something equals 0. When you have something like that, say a times b equals 0, either a has to equal 0 or b has to equal 0. One of those two things has to be true. So let's take a look at it in this case. So I've got either x plus 4 equals 0 or x minus 4 equals 0. What are my solutions for these equations? When does x minus 4 equal 0? X equals 4 or negative 4. So great. But let's keep something in mind. This was the equation that I started out with, right? So that's fine, x equals 4 works. But does negative 4 work? Does negative 4 equal 4? No. This is what's called an extraneous solution. It's a solution to the quadratic equation that we ended up with, but it doesn't solve the original problem. And so when you square both sides of an equation, sometimes you can accidentally introduce these extra solutions, and you have to get rid of them by checking your answer when you're all done and making sure, oh, okay, that's an extraneous solution. Now in WebAssign, they're going to ask you to denote, is this an extraneous solution? If it is, that's great. If it's not, that's fine. But on the test, you can do exactly what I did here. When you're all done, if there's an extraneous solution, just put a circle around it and cross it off once like that. So that's kind of an easy way. I don't even ask you to spell extraneous, right? It's a math class, so you're cool. All right, hopefully you take this message to heart because I do award points for checking your solutions when you're all done. All right. Let's move on down to example C here. And things are going to start getting a little bit more interesting for us. Example C. Square root of 2a minus 3 plus 3 equals a. Now there's a temptation that a lot of people have. They want to square both sides right away. That would not give you anything near what you expect it would. What you have to do is you have to isolate the radical first. Get the radical by itself before you square. And that's so important. I'm going to write it down here. Get the radical by itself before you square both sides. I think I gotta retire this pen. So what do I mean by that? What do I have to do to get the radical by itself in this particular problem?
Subtract 3.
Yeah, subtract the 3 from both sides. There again, that's that idea of the opposite operation. So I subtract 3 from both sides, and that gives me the square root of 2a minus 3 equals a minus 3. Okay, so cool. I got the radical by itself. Then what do? What can I do after that? Well, I need to get the a by itself somehow. Right now I've got a on both sides, but in particular my big problem is that I got that a underneath the radical. So how could I get that a outside of that radical?
Square root it.
Almost, not square root, but
Take one.
somebody said it.
Square.
Square it, yeah. So we want to square both sides. So we got the square root of 2a minus 3 equals a minus 3, and you're going to square both sides. And here's where there's going to be two places in this problem where people run into trouble. And this is one of them right here. When I square the left-hand side, let's see, Joelle, what are we getting when I square the left-hand side?
2a minus 3.
2a minus 3, good. So on the right-hand side, where a lot of people are going to make mistakes is they're going to write a minus 9 or a plus 9, whatever. But they're going to try and square it as if it's, you know, this squared plus this squared or this squared minus this squared. You can't just distribute the 2 there. I wish it were different. Instead, what you got to do is you got to take a minus 3 and multiply it by itself. You got to FOIL it out. So that's going to be a squared minus 3a, first, outside, inside, last, minus 3a again, plus 9. And before I did anything else, I would suggest you combine like terms. But if you want to do yourself a favor, put a little star here in your notes, because that's an easy place to make a mistake. It's the first thing I look for when I see people's work. I'm like, all right, did they square it out correctly? I mean, literally speaking, that's a couple points of partial credit, is getting from here to here. Now let's see if we can't go a little bit farther. What side of the equation do you want to collect the variables on, the left-hand side or the right-hand side? You could do the left, but because I got an a squared over here and it's already positive, I think I'm going to want to move everything to the right-hand side. But you could do the left. Ultimately, the left would probably be a little bit more work, but not a lot. So if I want to move everything to the left-hand side, I want to get rid of the 2a here. So that means I'll subtract 2a. What's going to get rid of the minus 3?
Plus 3.
Yeah, 3. If you notice on the right-hand side, I put those underneath like terms so that I can just kind of add things straight down. So it's going to be 0 equals a squared minus 8a plus 12. Pause for a minute here. Looking okay with this so far? All right. This is a quadratic equation. You've got a squared term here, that makes it a quadratic equation. Your best friend when trying to solve these things is to try and factor it. So this is why we did all that factoring work back in chapter 8. I know I'm going to need an A and an A here. And two numbers that multiply to 12 and add to negative 8.
Negative 6.
Negative 6 and 2. Perfect. Perfect. So if I have two numbers that multiply to 0, or two expressions that multiply to 0, then either minus 6 equals 0 or a minus 2 equals 0. Now you don't necessarily have to show this. I show this just because I don't want to lose anybody, but there's kind of a shortcut to the answer here. If you've got an a minus 6 term, then what's my answer going to be? Well, add 6 to both sides, or add 2 to both sides. What do you think is a shortcut in going from here to here?
Opposite sign.
Yeah, just change the sign on this term right here, right? If you have a minus 2, then your solution is going to be a plus 2. If you had a plus 6, then the solution would be a minus 6. Just like up here in this example, I had a plus 4, my solution was minus 4. Minus 4, solution's a plus 4. So kind of a nice thing you can do to make your life a little bit easier. So there you go. A equals 6 and A equal 2. All good? Good with that one? Well, let's see. Let's let you think a little bit. This is kind of a hint that I actually want you to think a little bit, because we're not good here. What do we got to do?
Check our work.
Yeah, you gotta check your answers. All right, and this is a perfect example of why you have to check your answers. So let's check both of them one at a time. We'll start with checking the 6. Thanks, Carol. Check A equals 6. So I'm going to put that into our original equation, which was this, square root of 2a minus 3 plus 3 equals a. Make sure you always put it into the original equation. So square root of 2 times a minus 3 plus 3 equals a. So let's squeeze in a 6 here and a 6 here. I always put a little question mark there because what you should be asking yourself is, does it work? Does this give me the right solution? So let's see what I get underneath the square root. I get 12 minus 3 plus 3, does that equal 6? Square root of 9 plus 3, does that equal 6? Yeah, I think we're good on that one. 3 plus 3 equals 6. So no worries on that one. Let's try the other one. I'll squeeze that in over here. Let's check A equal 2. So we're going to do the same thing that we did with A equals 6, just plugging in A equal 2. So let's see what happens when I plug in the 2. So that's square root of 4 minus 3 plus 3. Does that equal 2? Square root of 1 plus 3. Does that work? Square root of 1 plus 3 equal 2? What's the square root of 1? 1. So, oh wow. We did all the right work, but the answer doesn't check. So that makes it an extraneous solution. As far as the test is concerned, you can just do something like this. You can just say, okay, cross it off like that. Just one nice little check there. That tells me you understand that this is an extraneous solution without actually having to write the word. But on WebAssign, you are going to have to indicate that kind of thing. You'll see something like this, say extraneous solution or not extraneous. So they're going to ask you for that. Also, something else annoying about WebAssign, and no surprise here, they're going to ask you to put it in kind of order. They want the smaller solution and then the larger solution. So the first one would be 2, the second one would be 6. I'm not going to go on about that. You know, I find that annoying, but there's not much I can do about it. So, okay, there was a lot in that one. Let's take kind of a quick look back at that. So the first thing we had to do is we had to move this to the other side to get the radical by itself. If you tried squaring things right here, this would be a colossal mess. You would not be very happy with the stuff that you get. In particular, because you would have to multiply out the binomial square root of 2a minus 3 plus 3 times itself. It's just going to be a real big mess. So you want to isolate that radical. The other big thing that I asked you to star was this step right here. And when you square this out, you've got to multiply the binomial by itself. If you don't, all bets are off. A lot of these problems are designed to work out very nice, you know, so that maybe you have 2 nice solutions, one works, one doesn't, that kind of thing. But if you mess up this step, all bets are off. So, last chance on that one. Your chance for 1 then. So let's look at example D. This time I want you to do some work. I'll walk around and help out. So example D is square root of negative x plus 50 plus 8 equals x. Okay, so much like the last one, I'll walk around and try and help out. If you're watching this at some future date, then you can fast forward until I get rid of my pause button. And you guys can help each other out too. If I'm not able to swing by, then, you know, help each other out.
X to the second.
So it would be, but you don't want to square it here. You want the radical by itself first.
Oh, yeah. Oops.
Yeah, yeah.
Bless you.
It doesn't disappear, so we have negative x here, we have positive x.
Is that correct?
Except that'd be a plus 14.
Right. Yeah, it just didn't make sense, just a second.
Yeah, because the other way it wouldn't factor very well.
It's a little weird.
Nice, nice. Delta jump. Yeah, subtract it. So for all sides.
Okay. But your question is a good one, so I'm gonna actually brought that one.
Should be adding x to both sides. Should be negative 15x.
And you need to get the x, you need to get the 0 there, so that's when I'm gonna add the x.
Nice. Just think of multiplying it with 14. And what are the first two? Those don't add. What else?
They're both a negative.
Yes. There one step that I mentioned as we went through this, and it's to get the radical by itself first. So what that means is you want the radical by itself. So in other words, you have to subtract the both sides.
Okay, so what's the first step here in solving this? What do you have to do first? Was my suggestion just a minute ago.
Subtract 8.
Subtract 8. You want to get the radical by itself first. If you don't, it gets real ugly. So if you don't, and you're like, okay, well, I'll square both sides. Squaring both sides is going to lead to a huge mess. Don't copy this down, please. But you'd have to multiply the binomial by itself, and it just doesn't work out anywhere near what you're looking for. You get this times this, okay, that's squared, that works out nice, but then you got this term in here, which would be 16 times the square root of negative x plus 50. Yeah, it just doesn't do what you want it to do. So subtracting 8, that's a great start. It gets the radical by itself. negative x plus 50 equals x minus 8. And then what? Well, now we would need to get rid of the radical part. But now that you've simplified things to get the radical by itself, if you square both sides, it's going to do what you want. So I'm going to take and square the left-hand side and square the right-hand side. So equals x minus 8 squared. On the left-hand side, I get negative x plus 50. On the right-hand side, well, you got to FOIL this out. It's going to be x minus 8 times x minus 8. So x squared minus 8x again plus 16. Combining like terms,
Wouldn't that be 64?
pardon me, 64, yeah. 64. Combining like terms, x squared minus 16x plus 64. Now, because I've got a positive square term on the right-hand side, I think I'm going to move everything to that right-hand side. So that means getting rid of, say, the 50. The opposite of adding 50 is to subtract 50. So subtract 50 from both sides. And the opposite of negative x would be positive x. So I get 0 equals x squared minus 15x plus 14. And that factors. Who figured out how that factored?
Mine.
X minus 1 and x minus 14.
Nice. And hopefully you're getting kind of used to this, that if you change the signs, you can get our two solutions. So what are our two solutions?
X plus 1, x plus 14.
Perfect, yeah, 1 and 14. Beautiful. There's just one last tragic thing we have to take care of, and I say it's tragic because a lot of people forget it. What's that last thing I got to take care of here?
Check your
Look
work.
for sign.
Check your answers, yeah. Yeah, look for extraneous solutions. So I'll circle both of those and see if either one of them is extraneous. So I'll check x equal 1 first. Negative of something plus 50 plus 8. Does it equal that something? So let's find out. So if I put in a 1 here and a 1 here for my x's, then I end up with the square root of 49 plus 8, and I don't think that's equal to 1. So that's an extraneous solution. Just to give you an FYI or a heads up, sometimes one of them will check, sometimes both of them will check, sometimes neither of them will check. It's just going to depend on the problem. Even for myself, it's hard to look at these things in advance and know, do I expect 0, 1, or 2 solutions? You just literally have to check it. So let's check our other one, see if we're a little bit more lucky there. Check x equal 14. So let's see, negative 14 plus 50. I think this one seems a little bit more promising. So let's see. I'll put in a 14 here and a 14 here. A little question mark. This is going to be the square root of 36 plus 8. Well, that's 6 plus 8, and that does equal 14. So we're good. So this one works, this one doesn't. One's extraneous, the other one's not. Cool.
I have a question.
Yeah, please.
So for the solution, when we write the solution, it'll just be x equals 14, we won't need to write the extraneous solution also.
I guess it depends if you're talking on the test or on WebAssign. On the test, I'd be happy if you did it just like I did here. Just circle it and then cross out the extraneous one like that. And if neither are extraneous, that's good. I will be looking to see that you do the check. That is something that I award a couple points for. So maybe if this is like a 7-point problem, there'd be 2 points for the check. And I'm pushing you a little bit to make sure you do that check. I want to see that there. In a lot of problems in math, it's a good idea. In this one, it's no longer a good idea. It's actually a requirement. You have to check them. So now on WebAssign, they'll actually ask you to label them extraneous and not extraneous. So there'll be a little drop-down menu next to your answer saying, what kind of solution is this? Yeah, so, yeah, no, thank you. Anything else? You want one more like that last one more to practice? Or you want me to change things up a little bit? How good are you? You feeling confident? Feeling confident? All right. You can check this one maybe at home if you like. Let's try a couple other examples. What I like about some of this stuff is it's starting to get more applied, that is you can actually see areas where this could be used. There's an old problem that I used to use about civil engineering, but kind of lost track of that one. So let's do this one. Let me make that a little bit bigger. And for the life of me, I'm not sure how they actually calculated this, because the way I see this problem is that it's a kind of a trig problem or a Pythagorean theorem problem. Something we'll do in the next section. How far you can see before you can see before you reach the horizon, you can't see any farther. A lookout tower is built. The farther an observer is built, the farther an observer can see. That distance d is called the horizon distance measured in miles. It's related to the height of the observer measured in feet with this formula, d equals 1.4 times the square root of h. So that's where we should kind of pick things up. Let's write that down. So this is example F. D equals 1.4 times the square root of h. How tall must a lookout tower be to see the edge of the forest, which is 26 miles away? So, So what variable are they giving you here?
Distance.
They're giving you the distance. They're giving you d is 26 equals 1.4 times the square root of h. You've got a couple choices here as to how you solve this. It kind of depends on you and what your comfort zone is. You could square both sides as it is because you kind of have the square root by itself. Or you could take and divide both sides by 1.4. And what's nice about that is that it gets that square root term by itself. So, now unfortunately, the left-hand side doesn't work out to be anything really pretty when you do that. That's okay, we'll just leave it as is. 26 over 1.4 equals the square root of h. What do we got to do to solve for h?
Square root.
Yeah, square both sides, right? So that's just going to be 26 over 1.6 equals square root of h. Square both sides. Right-hand side is just, it's h. The left-hand side, well, might want to take out a calculator to do that one. They are going to ask you for a decimal answer, so let's pull up the calculator here. All right, so 26 divided by 1.4 gives me this crazy number. Now, kind of a nice, easy, quick way to get the square of that is just to hit the square key right over here. And notice what your calculator does. It takes the previous answer, which is 18.57 something, and when we square it, we should get something a little bit more than 330, I'm guessing. Actually, probably like, 340. All right, there we go. So square both sides, and that tower should be about 344.9. Do pay attention to the problem. They want you to round to the nearest foot. So if I get 344.89 rounded to the nearest foot, that's going to be 345 feet. How are we looking on that one? That one's good?
That was easy.
Good. All right, cool. Glad to hear it. Let's try a couple more here.
That was how tall it was supposed to be, right?
Yes, 344, so I'm not sure my chicken scratch came out too nice. Let me kind of clean it up a little bit, but that's 345 feet. Yeah, so good on you to pay attention to the units. Thank you. I think I mentioned something like this when we did variational problems. I said the power of the wind is related to the cube of its velocity. So, for instance, if you had some kind of a hurricane that was headed towards the coast, and all of a sudden the winds grew 10% stronger. Yeah, 10% doesn't sound like too much, but when you realize that the power of the hurricane is proportional to the cube of the velocity, then a 10% increase in the wind speed is really like a 33% increase in the power of the hurricane. So when you go from 110 miles an hour to 121 miles an hour, it's a big jump in the power of the hurricane. That same kind of relationship formula is expressed in example G. The power generated by a certain windmill is related to the velocity of the wind by the formula V equals the cube root of P divided by 0.02, where P is the power in watts and V is the velocity of the wind. Find how much power the windmill is generating when the wind is 22 miles an hour. Round your answer to the nearest whole number. Your answer is going to be in watts. So, all right. I guess there's one number that we got to keep track of here, and it's 22. Where am I going to put in that 22?
Replacing V.
Yeah, replacing V. So 22 equals the cube root of P over 0.02. And now the goal is to solve for the power. What's a little bit different about this one than all our other problems up till G? Yeah, you're dealing with a cube root. Now when we're dealing with square roots, we would square both sides to solve. What do we do to solve when we got a cube root? Cube both sides. So I'm going to take 22 and we'll cube both sides. Okay. I have no idea what 22 cubed is. 10,648 equals P divided by 0.02. Not quite done, but getting closer. What's the opposite of dividing by 0.2? Multiply by 0.2. So if we multiply by 0.2 on both sides, we should get an answer somewhere in the 2000s, I'm thinking. No, maybe even less than that. On the right-hand side, we get some nice cancellation. That cancels there. And on the left-hand side, we just get to multiply. And 202.96 equals P. Be careful when you put in your answer. It doesn't want the exact answer like this. It wants you to round it to the nearest watt. which in this case is 213 watts. Nice, nice. Let's practice one more with a cube root. Comments or thoughts on example G before I move on to the last example? You getting better with these? Yeah, okay. All right, thank you. All right, so example H. One last equation. So example H. Cube root of x plus 5 equals -1. Maria, I think we should start off with this one.
Cube everything.
Yeah, cube both sides.
So x plus 5.
Not quite.
Positive 1.
Which one, -1 or +1? So, yeah, negative. So the trick is when you're cubing -1, or when you're raising -1 to any power, you want to look and see, is this even or odd? If it's odd, then you're going to end up with -1. If it was even, you'd end up with +1. So, good. Awesome. What does x equal?
-6.
-6. Cool. You should still check it, just out of good habit. If you plug that back in here, let's see if it works. So we'll check cube root. If I plug in a -6, the cube root of -1 is -1. So it checks. Beautiful. Okay. Looking good on that one? All right, let's put this one in the books. Good luck on this homework.